So this is a video for 7-6. Should have done the exploration in class. Hopefully that worked out. Okay, so first we'll just fill in these theorems here. If a line parallel to one side of a triangle intersects the other side, then let's see. Okay. Just take this line out for you. Okay, and this is just right in the book. It divides those sides proportionately. Okay. The one down here is a corollary. It follows because if you kind of look at the picture, if I can extend the page, it kind of looks almost like a triangle if you extended these up. So if three parallel lines intersect two transversals, and again, we did someone similar to this where we said if three parallel lines divide a transversal into equal parts, then they divide another into equal parts. This is a very similar idea. Then they divide the transversals proportionally. And this is just saying, if I put another one here, that if AD is parallel to BE, which is parallel to CF, we're going to use those IIs to be our parallel symbols, since that's a little difficult for me to do. Then AB over BC is equal to DE over EF. That's all that's saying. In the next one, you did this again in the exploration. So I'm just going to fill it in with the words that the book uses, but you should have gotten the idea from there. It divides the opposite side into segments proportional to the other two sides. And again, if you need the letters for that, you should be able to look at your exploration and what we saw there. So when we go here, we're just filling in some questions using that. So CD, so you'll see CD is part of this and DA. So those are two sections of one large side. Okay, so that's going to equal, make sure the left side talks about the same thing. So CE over BE. Okay, in letter B, if CD equals 3, so you can just use the proportion right above it. DA is 6 equals, okay. Now what you need to be careful of here is CD is here, DA is here. DE is here, and you looked at this in the exploration, so please be careful about this. So DE is not like the segments of the one side, it's a whole side of the small, so that's going to be compared to the whole side of the large AB. So you can't go 3 to 6 here. You're going to go 3 to 9, and the 9 is coming from 3 plus 6 because I'm doing small side to large side. I'm using the similar triangles here, not that, I wonder what they're calling it, the triangle proportionality theorem, or some people call it the side splitter theorem. Okay, so DE is 3.5, and that'll go for X. And you guys should be able to solve that one on your own with cross multiplying, so I shouldn't have to hopefully write all of that. Getting 10.5. Okay. In the next one, I have CB. So again, just be real careful. CB is a large side to EB. CD to DA. Okay, so let's label this to make it a little, well, I don't know if that's going to make it clear or not. And the large side is 12. So I'm going to kind of write that out here. CD is 6. and I'm looking for dA, which is x. Now, because this whole thing is 12 and this is 8, I do know that this is 4. And what I'm doing is I'm constantly saying, okay, what am I comparing in one ratio? What am I comparing in another? So if I'm going to go CD and DA, again, there's more than one way to do this. I'm going to make sure I go CE to EB. That length of 12 helped me to figure out what CE was. So I'm going to go 4 over 8 equals 6 over x. And when you solve that, you should get x equals 12. Over here, a similar idea. A is 2, B is 3. This is using that corollary. Then C is 5 over what? And again, if you multiply that, you should get 7.5, I believe. So B 3 times 5 is 15, and then divided by 2. Okay, so the next one, letter B, there's several ways to do it again, and you guys can always pause, try them, and come back here to check. I'm going to go 4 over 8, and I'll do C over 5. And for D, I'm just going to call that x for right now. I know that's not what I'm looking for, but I'll get x equals 10. Now check what the problem asked for. It asked right here for C plus D. So 5 plus 10 gives me an answer of 15. So 15 is my final answer. Goodness, I have several problems. Over here, we'll go through true, false. So you have to just make sure, again, that you're comparing the same thing. So I have FA over HA. So I have the whole over kind of this bottom part in letter A, FB over TB. Okay, well that is going to be true. That does work out. So FT, okay, small side, over FH, okay, so that was small right to small left, okay, is going to equal FB, large right, over FA, large left. So that one is also true. Over here, FH to FT, HA to TB. So again, FH, and these will be true. And I know some of these you're like, wait, this isn't going from where it is. But a lot of them, if you use your properties of proportion with the original triangle proportionality proportion you would get here, you're going to be able to get to a lot of these. I think the easiest way is just make sure they're comparing the same thing. So here I have FA over FH. Okay, so I have the long side over the short side. And FT over TB. And those are comparing different things. I went long side to short side, part to part. That's not the same thing. So this one's going to be a false. Sorry. I have FH over AB and AH over FT. And those just aren't matching things that are very similar at all. So this will be a false. H. Okay, FA over FB, AH over TB, that's true. And if you have questions on exactly why these work out, I can show you this. I'm not going to go into all those. If you follow what I talked about is making sure, you know, your one proportion is talking about the same thing on the other side, you're good. But if you have a question, you can write that in your notes and you can ask me tomorrow in class. Over here, the first thing to look for, what I get worried about with the angle bisector, triangle angle bisector theorem is you tend to start to look for things to be similar, and there isn't really something there unless you go through that proof. So just please be careful with that. The proportion we're looking for is 12 over 24 equals 10 over, and in this case we don't know this, so I'm going to call it x minus 10. Okay, so then you'll solve that. I guess I'll probably do it the longer way. Some of you might see a shorter way to do it. Not really shorter, but smaller numbers. Let me just check my math there for a second. So that gives me 260 equals 12x. And that should give me x equals 21 2/3, or 21.6 repeating, 21.67. Oh, nope, I did this wrong, sorry. So that's going to be a 240. That was a 24, I read it as a 14. Add, that gives me my 360, and that makes it a much nicer number of 30. Okay. The other faster way I could think of doing it is 12 over 24 reduces to a 1 to 2. I have a feeling it should be 20. That should probably be 20. I'll come back to that. Here, I would go x over 1 equals 8 over 2. X equals 4. Oh, this is where I messed up. Sorry guys, let me redo this one for you. Still getting 30. Alright, you guys can correct me on that. I'm a little tired from being out with my daughter, so I didn't get that. Alright, so again, set that up. I think you're going to be okay. Oh, I'm sorry, now I know what I did. X does equal 30. That's the whole length, remember. So this piece is 20. 10 to 20 would reduce to a 12 to 24 ratio. So X actually is 30. I was right. Okay, make sure you have these. We'll have, you can answer questions. My plan tomorrow is you can answer any questions on 7.4 through 7.6, and then Wednesday we review and Thursday we quiz.